So in this question, we are given charges plus q each placed on the x-axis at different positions. That is, x is equal to 1 meter, 2 meter, 4 meter, 8 meter, and so on till infinity. And we need to find the net force on a charge of magnitude plus q0 placed at the origin. So couple of things to note. First is, since these charges are positive and this charge q naught is also positive, all these charges will repel q naught, and since it is repulsion, all the forces on q naught will be towards the left, that is towards the minus x-axis. So we know the direction of the force of all these charges on q naught. So now the force on the charge plus q naught due to charge at x is equal to 1 meter will be 1 upon 4 pi epsilon naught q naught upon 1 square, and due to the charge at 2 meter will be 1 upon 4 pi epsilon naught q naught upon 2 square, and so on. And as we just discussed, all these forces will be along the negative x direction. Now we know the forces because of these charges on q naught, but what is the net force acting on q naught? And luckily for us, Coulomb's force follows the principle of superposition. So the net force on q naught is the vector addition of all the forces acting on q naught at O. And since anyway we know that that direction of all these forces is towards the negative x-axis, therefore we just have to add these forces so as to get the total force. Now if you see, if we take out 1 by 4 pi epsilon naught q naught, which is common across all these terms, we get a GP, where the GP is 1 plus 1 by 2 square plus 1 by 4 square plus 1 by 8 square, and this is an infinite GP. And what is the sum of an infinite GP? That is equal to A into 1 upon 1 minus R. And for the GP here, A is equal to 1 and R is equal to 1 by 4. Therefore, the total force F net here is equal to 1 upon 4 pi epsilon naught q naught into 1 upon 1 minus 1 by 4, which gives F net equal to 1 by 4 pi epsilon naught 4 by 3 q naught, and the direction of this force is towards the minus x axis. So the correct answer is option number C. Note that the aspects of Coulomb's law we have used here is one, which is the force between 2-point charges, which is given by this formula, and this is the magnitude. And the other aspect is that the direction of the force between the 2-point charges is along the line joining the two charges.